Good afternoon, everybody, and welcome to another Geo-Institute live stream. If you are eagle-eyed, and I think you are, you will notice that this is our first live stream of 2025. So if you had a little bit of a panic attack and you said to yourself, will the Geo-Institute live stream if you are 2025? Worry no more, we are. My name is Brad Keeler. I'm the director of the Geo-Institute, and thank you for joining us for our third episode of GI Books Rock. You may wonder, why did we call it that? Well, because rock, geotechnical, it's as simple as that. If you don't know anything about the Geo-Institute, after you watch this amazing interview today, you should head over to geoinstitute.org, and there you will find out all kinds of incredible things about us, including that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and or geologists, and that we are part of the American Society of Civil Engineers. If you like what you see today, and let's all nod in unison, will they like what they see today, everybody? You should click like, subscribe, and get notifications, and we will let you know every time we post something to the YouTube channel. With those important things out of the way, we now turn to the matter at hand. Books Rock is here to promote recent Geo-Institute and ASCE publications. And that is what we plan to do today with two of our editors of recent GSP, Mike McGuire and Elise Hummel. Hear from the ASCE Publications team to tell us a little bit about it and about ASCE Publications is Leslie Connolly. Leslie, welcome.
Thank you, Brad. Yes, today we're talking about ASCE Publications. ASCE is the leading publisher of civil engineering content. We publish a variety of books and standards, and today, as Brad mentioned, we're talking about a technical report, or GSP, from the Geo-Institute. Technical reports are known to present the use of cutting-edge technologies or methods in a specific engineering application. This theory manual, GSP 356, provides a comprehensive technical information regarding the LDC method, and the user guide, which is associated with it, provides information on using the GGB3 spreadsheet, which Mike and Elise are going to be talking more about. Brad was going to share the landing page, which has more information on how to purchase the books. But actually, if you purchase both books together, you get a 10%. There's a promotional code there, GIESE10, which you can use to purchase both books together through the ASCE library. Thank you very much, Brad.
If there is one thing that GI members love more than geotechnical engineering, it is savings. And so I'm very happy we were able to work out a little something there. Thank you, Leslie, for that. Now, running the show today, as only he can, is Geo-Institute past president Alan Cadden. If you have questions, Alan will remind you of this as well. If you have questions during the interview, you will see a chat box immediately to the right of where you are watching this video. Put your questions right in there and we will get to them, I promise. Now, GI past president Alan Cadden.
Thanks, Brad. It's always a great honor to have you introduce me and rope me into these things. So appreciate it. I'm looking forward to this as well. I'm Alan Cadden, principal with Schnabel Engineering. Been around here for a long, long time. But even more importantly, Schnabel's been a member of the Center for Geotechnical Practice and Research at Virginia Tech for almost that long. And I had the great privilege of knowing Mike and Elise through CGPR down there, and look forward to this book review. So welcome to Books Rock. We have Mike McGuire and Elise Hummel here today. As you heard, they're co-editors of the theory and the practice manual for GeogridBridge 3. So with that, I will actually give them a second to introduce themselves. Mike, you want to take a shot there?
Sure. So thanks a lot, Alan. So I'm Mike McGuire, and I'm a current associate professor and department head in the Department of Civil and Environmental Engineering at Lafayette College. And you're going to hear more about Lafayette College because Elise is a alumna of Lafayette College. It's located in Easton, Pennsylvania. Great institution that turns out great students. Just a small bio on me. So I grew up outside of Philadelphia, did my undergrad at University of Pennsylvania, and then upon graduation, I had an interview at the Westchester office of Schnabel Engineering with Alan Cadden back when I was looking for my first job. And so I ended up working at Schnabel for 6 years in their Richmond office. And then I went to graduate school at Virginia Tech, got my master's and PhD there. My PhD work is very closely related to what we're going to talk about today in column-supported embankments. At Lafayette, I do a lot of teaching in geotechnical engineering, in engineering design. I also have continued to do research at Lafayette in column-supported embankments, stability of walls and slopes. I'm very interested in foam glass aggregate. I've done a fair amount of work in that area. And I've most recently been working on a project looking at the load deflection relationship of post and beam traffic barriers behind segmental retaining walls. So happy to be here today, and I'll turn it over to Elise.
Awesome.
Thanks. Yeah, my name is Elise Hummel. I was an undergraduate student at Lafayette College a few years ago. I worked under Mike, and the work that we'll be presenting today is based off of that period. After graduating undergrad, civil engineering degree, went to Virginia Tech, sort of followed the train that you see the other presenters here with. And then I'm currently working at SpaceX down in Boca Chica, Texas, as a launch engineer for the Starship program.
Awesome. And fortunately, they delayed the launch, so we have the privilege of your presence here today. So
just for this, yeah.
Just for this. I appreciate that. I'll have to thank Elon for us. All right. So let's get into this. First of all, I want to remind everybody that please submit your questions in the chat box. There's plenty of time. We'll try to get to everybody's questions we can, especially if you're a CSE enthusiast or a Hokie. So you're definitely welcome. But let's start at the very beginning. I understand that a few years back, we had an interesting turn of events that created a perfect opportunity to work on this project. Can you give me a little bit of the backstory as to how you kicked off this GeoBridge 3 effort?
Yeah. So yeah, I'll take a stab at this, and then I'll hand it off to Elise. I'm going to kind of roll the clock back a bit further just to kind of lay out the full timeline here. So column-supported embankments started in practice in Europe in the 80s, and they really started to be used in the US in the mid 90s. There was an embankment built to support a tank of molasses in Philadelphia, and then an embankment to support some light rail, part of New Jersey Transit. And I believe that Jim Collin was involved in both of these projects when he was working at Tensar at the time. He's now president of the Collin Group. So this work, and so Jim Collin was quite involved in this in the U.S. So was Jihan, who's at University of Kansas, and another past president of the GI. And about in the early-ish to mid-2000s, George Fills at Virginia Tech became interested in column-supported embankments and began some research, and had a PhD student, Miriam Smith, and together they developed the first version of the Load Displacement Compatibility Method of doing settlement analysis for column-supported embankments. And so we're going to be talking more about that today. That first effort produced a manual through the Virginia Transportation Research Council that was dated in 2006. And that's when the first spreadsheet implementing GeogridBridge was made. And it was called GeogridBridge, based on sort of the materials that were considered to be used at the time. So thinking about GeoGrid, which is still the most common form of reinforcement used in these systems. So you can use high strength fabric. And so this spreadsheet, an Excel spreadsheet, was managed by the Virginia Transportation Research Council. And that product stood for a while and it began to get traction. There's a couple things that we'll talk about that this method has some pretty distinct advantages over some older methods. In the mid-2000s, another effort was launched, and this is when I was a PhD student at Virginia Tech, as well as one of the co-authors or co-editors of these volumes, Colonel Joe Sloan, who's the professor and department head at the U.S. Air Force Academy. And so both of us were doing our PhDs under George at the same time. We were doing different things related to this method, and Joel was the one who was most involved in the Strategic Highway Research Program, Phase 2, the SHARP 2 project, where they were looking at ground improvement methods. And it was that project that gave birth to Geotech Tools, which is a tool that many folks in the Geo-Institute use to get information about ground improvement. And there's a section on column-supported embankments in there. And that effort presented an opportunity to update that original GeogridBridge spreadsheet. So it was using that original spreadsheet, but there was new capabilities added based on work that I did in my PhD, work that Joel did in his PhD, particularly looking at load transfer, looking at triangular column arrangements, for example. And so then there was a second version, and that second version of the GeogridBridge spreadsheet lived on Geotech Tools. And there was some supporting documentation. But, and now I'm getting to your original question, there wasn't any single source of comprehensive information that reflected all the evolution of the method. There were, you could find it in dissertations and papers. And so this was always something that Joel and I kind of wanted to do, but we knew it was going to be a big lift. And, there's lots of stuff going on. And the opportunity that presented itself was, it was the pandemic. So it was one of the silver linings of the pandemic. It really, because we couldn't do field work or other types of research, kind of a desktop project that could involve students was ideally suited for that time. And so I'll turn it over to Elise. She can talk a little bit about her perspective because she was involved in this as a student, as well as the fourth editor of these volumes, Eric Hunstein, who's a engineer at Haley and Aldrich's office in Portland, Maine. So Eric graduated Lafayette in 2021, and Elise graduated in 2022. So Elise, do you want to talk a little bit about your experience?
Yeah, Eric definitely did pretty amazing work and gave me a really nice jumping off spot to pick up from his senior capstone at Lafayette. The year that Eric was doing his capstone was 2020 full shutdown era. And so I think he really benefited from being able to put in a ton of really hard work during a time where he couldn't necessarily be on campus, and it lended itself really well to sort of Zoom meetings. I picked it up the following year, and it was also really helpful to be able to collaborate with Joel and his student over at the Air Force Academy as well, because logistically we had the infrastructure at that point to do so. And so it was really actually quite a good experience to be able to interact with all sorts of people and meet different folks in the field who are involved and engaged in this work in a way that would have been much more difficult a few years prior.
Yeah. And unlike the first two versions of GeogridBridge, the spreadsheet that runs the LDC analysis, when we embarked on this project, we started with a complete clean sheet. So the third version, the current version of GeogridBridge, is an entirely ground up build that uses different underlying techniques to arrive at an equilibrium solution that are faster and more stable. And so we can talk more about that depending on where the conversation
Great.
goes. Yep.
Cool. So as you kind of work through that process, at what point did you start looking at, interaction with the GI's ground modification committee, or start seeing how it's going to impact geotechnical tools? How'd that process go?
Yeah. So we kind of took it upon ourselves to do this. And so it was one of those instances where we were chugging along doing the work, and then it kept getting bigger and bigger, and like the product kind of looked kind of better and more robust. And we're like, man, somebody should kind of know about this. So I sit on the Geosynthetics Technical Committee, and so that technical committee is the one who sponsored our efforts. So there were two. There was one geotechnical special project that helped support this work once it was underway, and it helped Elise and Eric do their work and help us move from really going from what we thought might have been a report that could have lived on geotech tools to moving this all the way through ASCE publications. And so that was an evolution, and it was, a lot of credit goes to the Geosynthetics Technical Committee for alerting us that, hey, this could be an ASCE publication, and guiding us through the process, and ultimately doing a very nice technical review of the publications as they move to final production.
Cool. Yeah, it's a pretty extensive theoretical recap of all the background in the geotech tool or the GeogridBridge philosophy. Just a reminder, if anybody has any questions, please feel free to pop them in the chat there. I'll kind of weave them into this conversation as we go along. So at any point, throw something in the chat. Mike and Elise, can you talk a little bit about, you talked about the background, the back end of the system being more stable, completely rebuilt from the ground up. Are there other big concepts in GeoBridge 3 that weren't in 2? Have we taken it another step?
Yeah. Elise, do you want to take a stab at that? Or?
Yeah, I mean, one of the main things that I worked on was adding capability to run Monte Carlos and vary your soil parameters as a part of your analysis. I think, like, as an industry, we're definitely taking probability analysis much more seriously, and we have the computational power to do so. And so it has a fairly robust, like, probabilistic component to it at this point that you can choose to run or not. And I think that is like a major benefit to this version of the sheet. It also has the ability to select which mobilization of soil arching theory you want to go by, which allows users a lot more flexibility in their design, which is also something that was not available in previous versions of the spreadsheet, and reflects recent work that was done in the field related to column-supported embankments and the scope in general.
Yeah.
Were you an Excel expert before you started this project, or did you just become one once you worked through it?
I was forced to become very familiar with VBA, yeah.
Yeah. No, it was great. It was really great. Elise was very persistent and just dug in, and as this thing kind of got near the final stages, I was looking at her Visual Basic codes and like, wow, this is pretty good. This is better than, I'm a pretty brute force coder where it's just kind of like clunk, clunk, clunk and goes through. And Elise's code was a little bit more elegant than what I typically produce. And elegant tends to run faster.
It just takes some fresh eyes sometimes.
Yeah. So
yeah, I do have a question from one of your co-authors here. I did a little homework ahead of time here and twisted some arms. So Jim Collin threw a question at me here. He wants to know, column-supported embankment design is complicated and includes many modes of failure, including settlement between columns with and without a load transfer platform. structural or geotechnical capacity of the columns, global stability, lateral spreading, and lateral squeeze. So of all these different modes of failures, what does GeoBridge 3 consider and what's left out? What else do we need to be paying attention to, and what are some of the key things to watch for?
Thanks, Jim, for the question. And I know that Jim already knows the answer to this question, but so for the benefit of the audience, in a nutshell, GeogridBridge 3, which implements the Load Displacement Compatibility Method, it's a settlement analysis. So we're doing a settlement analysis of a 3D problem where you have soft ground with stiff column elements in some regular array, square, rectangular, triangular. You can have a load transfer platform that may include one or more layers of reinforcement. And then you have your embankment layers. And GeogridBridge 3 can is able to allow you to specify up to 20 different soil layers that comprise the embankment and the subsoil. So there's a lot, again, getting to that flexibility that Elise was talking about. So this is doing a settlement analysis. There are components of the analysis that are considering the 3D nature of this column array. So the load transfer with mobilization of the reinforcement, for example, is a 3D analysis. Mobilization of soil arching as shear deformations develop in the embankment layers, that is a 3-dimensional analysis. Down drag or drag force along the columns, that we handle as a 3D analysis. Once we then get the stresses in the soil, we use a 1-dimensional compression analysis. So if it's a fine-grained soil, we use your conventional 1D consolidation equation, and if it's a granular soil, then it's just a 1-dimensional elastic compression. In doing this settlement analysis, we need to do a couple additional things. We need to look at the strain and tension that develop in the reinforcement. So that allows you to do a check of that material to make sure that it is, you're selecting the right material so that there's some mobilization, but you're not overtaxing it. And you can also look at the stresses in the columns, and you could use some of that information to look at your geotechnical and structural capacities for those columns. But as Jim alluded to, we do not do lateral spreading analysis in this spreadsheet. We do not look at lateral squeeze or extrusion of soft material between the columns. We do not look at global stability in this spreadsheet. Also, our settlement analysis only goes down to the estimated neutral plane of the problem. And so any compression of columns or soil below that neutral plane, that is a separate external analysis that the user needs to do using a method of their choosing, such as the equivalent footing method that we use in deep foundations. So that's, I think I've captured. Elise, did I miss anything? What's in and what's out? Yeah.
In your experience of working with column-supported embankments, those things that aren't included, is there one of them that you think is either really important to stay focused on or often overlooked, or any words of wisdom you have for the overall design?
I'm sorry, I looked at the chat for a second. Can you just restate the first part of that question?
The things that aren't in GeoBridge 3, which ones do you see in your experience as being maybe one of the more critical items that we tend to overlook?
Oh, great. No, excellent question. So there are, some of them, it's maybe not necessarily which was most critical, but I think it's which one do we have a decent enough design methodology to address. So the lateral spreading tends to be, this is lateral spreading of the embankment. That is we have fairly mature analysis methods for that. and you're just looking at kind of making sure that the material doesn't slide on the reinforcement if there's in there, making sure that that reinforcement has adequate strength and stiffness. The ones that I've thought quite a lot about, and I know that Jim Collins thought quite a lot or thinks quite a lot about, are the lateral squeeze, where you have material that, particularly if you have board displacement columns that you're using, so you're pushing material out of the way, and so that material's got to go somewhere, and so that can cause horizontal ground movements that can impose movements that you don't want beyond the embankment, and you can also impose bending moments on columns that aren't necessarily designed for that. So I think that's a really important design check that doesn't necessarily get all its due attention. And the other one is global stability. There was, I think, some understanding or kind of belief early on that because of these strong column elements and the high strength reinforcements that were used in these embankments and the high quality embankment material is typically used, that global stability may be not of a large concern. And I think that reality has proved otherwise, that there are cases where we very much need to be paying attention to global stability. And it's a hard challenge, and it's the subject of many ongoing research efforts, including one by Dr. Aaron Gallant at University of Maine. He has a PhD student who's currently really working on this. And I've done a bit of work on this as well. And Elise and I are both co-authors on a paper with Jim Collins looking at global stability of these systems.
Great.
Yeah.
Thomas Fennessy asked, you spoke about the vertical layering of the subsurface. Does the method address, and maybe the GeoBridge 3 tool, does it address the lateral variation of subsurface conditions at all?
Elise, going to take a shot at that?
It's sort of similar to a lot of sort of slice analyses where you just have to take different sections if you think there's going to be lateral variation. To some extent, I mean, the Monte Carlo, I don't think you can vary the depth of a layer, but you can vary the parameters within a layer. And you can vary those to different amounts by layer. So if you have a clay layer that you have a lot of varying information on, but you have like a super solid sand layer in there that you know a lot, you don't need to vary those parameters by the same amount, which can help. But there's not a way to run one single analysis that considers directly lateral variation.
So curious, you mentioned the Monte Carlo and the probabilistic analysis that's built in now. As you were going through this process, I assume you did some checks between the old version and the new versions, and just curious, was there something that you picked up by doing this more advanced, probabilistic analysis that surprised you that you wouldn't have picked up in the previous methods?
Yeah, that's a great question. So the motivation for introducing the probabilistic component, Joel and I think this might have been the paper that Dan Vandenberg at Tennessee Tech was also a co-author on. We did a paper a number of years ago where I had kind of hacked a version of this, the second version of GeogridBridge 3. So I created like a separate spreadsheet that just like called the spreadsheet recursively. And so we were able to do these Monte Carlo analyses pretty inefficiently, but we were able to do them. And the kind of goal of that study was to see the impact of looking at different parameter values in a probabilistic framework, and how sensitive each parameter value is to the result that you get, because some of these parameters are relatively routine things, like say unit weight, and a lot of the other parameters, like what friction angle do you use, what value of Young's modulus do you use? And that, Young's modulus is an example of a parameter that we as geotechs typically have a hard time like nailing down to a single deterministic value. And so knowing that we do have a number of input parameters, each with uncertainty associated with them, what that uncertainty, how strong of a lever does it has on the end result? And so what we found was good in that at least in the cases we looked at, the Young's modulus for sand layers doesn't really have a strong bearing on the result typically, whereas the compressibility parameters of a clay layer do have a fairly strong bearing. So you're getting that compression ratio and recompression ratio and stress history dialed in, as you would expect from just a regular consolidation analysis. That has a pretty strong bearing on the result. And so that as a designer, I think that gives you some framework of like where to put your mental and in some cases financial resources to further, refine your estimate of those parameters. That, hey, maybe it's worth doing a few more consolidation tests to really nail down the characterization of our clay.
But I thought if we were doing ground modification, we didn't have to worry about any of that stuff anymore.
Well, you got stiff column elements, and they're helping you out. But above the neutral plane, that soft ground is still a player.
Yeah. Well, realistically,
and you need that deformation. You need that differential settlement, or your geosynthetic reinforcement does nothing for you for load transfer. You got to have that trampoline effect develop.
Gotcha. And to be honest, we need that data just to determine whether we need ground modification in the first place, right?
Exactly.
So otherwise, we're kind of guessing. So I do have another question here. Please add more questions to the chat. Want to hear from you out in the audience and hear what burning questions you have out there. But Sean McGowan, sorry. You mentioned that the grids and you mentioned GeoGrids in the embankment support, but early in the development, a very substantial GeoGrid called ParaWeb was used in the UK. Are you familiar with whether that's being used in North America now? And maybe is that impacting anything?
Yeah, I think ParaWeb is used occasionally, but it's the market's really sort of shifting to PET GeoGrids. I think that's the majority of the specified materials for the load transfer platform. There still are cases where some people are using high strength fabric, but as it's interesting, kind of early on there was almost more experimentation with different kind of types of columns being used, and I think now as the technology approaches something akin, looks pretty mature, people are using kind of very similar systems, PET grids, and you see a lot more board columns rather than driven columns at this point.
But it doesn't exclude driven. We've seen some recently, even with timber piles. So
yeah, and there's some really cool things that some secondary benefits with timber piles. There was a study, I think it's a Dutch study, that highlighted that if you use a timber pile load transfer platform, you're sequestering a lot of carbon in the process, because these things are going to be there for a long time, hopefully.
Yeah, rather than generating with all that cement. So
yeah, exactly.
Just kind of curious, and trust me, it's been a while since I've used GeogridBridge 2, but there were some projects. I remember some intricacies with interpreting parameters in the model. Are there things in GeoGridBridge 3 that maybe in all of them that are parameters or input features that we tend not to really use correctly? Are there some things, words of wisdom or caution you can give us when we're using these tools?
Yeah, so this is something that I think Elise and I both worked on. So I'll give we'll tag team this one. So it's the second geotechnical special project that the Geosynthetics Technical Committee supported at Lafayette was looking at defining the stiffness of the reinforcement. And so in our notation, we use a capital J for that. And it is So it's this the tensile stiffness. Okay, like, well, what tensile stiffness? Reduced. Considering what? And so we want to consider a reduction factor for installation damage. We want to consider a reduction factor for any sort of deterioration of the material over the service life, and we also want to consider a reduction factor for creep. And that was the one that we really focused on, and that is often the largest reduction factor to estimate the stiffness. And if you look at most geosynthetic product data sheets, if they do suggest or recommend reduction factors, it's for the ultimate condition as opposed to a service level of strain condition. And so as a designer, what do you do? Do you use the reduction factor for the ultimate condition at a serviceability limit of strain, say 5%? That's typically what we assume in these analyses. Although, GeogridBridge will calculate the equilibrium. It actually solves for the strain rather than assuming a strain. But you need to specify. You need to figure out what value of J to use in the analysis, which means you need to evaluate what value of reduction factor to use. And in some products, it would be conservative to use the reduction factor at the ultimate state. And in some products, it could be slightly unconservative, or even more than slightly unconservative to use the reduction factor. And so Elise got involved in a project that I was working on with another undergraduate student. And this was, again, a big, we got a lot of help from the Geosynthetic Technical Committee on this. So there's a lot of manufacturers that are represented on that committee, and they were very supportive in providing us with isochronous curves that allowed us to interpret creep reduction factors at any strain that we wanted to, and evaluate if I know the creep reduction factor at the ultimate state, what might be the creep reduction factor at the serviceability limit of strain. And we came up with a model to estimate the serviceability creep reduction factor. We did a comparison, and Elise helped on this effort and is also an author on the paper that we produced, and we presented that at the 2024 Geo-Congress. So it's a fairly recent paper. So Elise, anything to add on that? Yeah.
I mean, the other thing that I would add is that I think one of the really large benefits of putting all of the effort that we did into these manuals is that we tried to be incredibly explicit on, like, this is what this parameter means, and, like, this is how you get to it. There's a ton of background and derivations of the different equations that we're using within the sheet. And so those that are interested in, like, fully understanding what they're putting in, which hopefully is most of the users, they have the resources necessary to do so, which some of the things I think before could have been a bit ambiguous. And so I think that was a really huge goal of the user manuals, both the theory and the user manual, to ensure that everybody was very clear on how to properly use the sheet and what the implications of their inputs actually means to the end product.
Awesome. Yeah. Thank you, because up till now, it's been, fortunately, we had a good relationship with Dr. Phil, so we could call him and try to get the inside scoop as to, what some of these parameters really meant. So that appreciate you putting this all together now. Let's see here. Oh, I have one more question from Jim Collin here. He says, GeoBridge 3 was originally developed to calculate settlement for a unit cell. Generally applies at the center of an embankment, but the unit cell really doesn't apply as we get towards the edge of an embankment, particularly when we have an MSE wall, as we see quite often, to minimize the embankment footprint. So what sort of analysis would you do in the cases where this cell theory really doesn't necessarily apply? What would you do next?
Elise, want to take a stab at that?
You got it.
All right. So, all right. So as I said, we do like a it's a three-dimensional problem, right? But it's a three-dimensional problem that we assume is a broad lateral extent. And so you can have a lot of these systems increasingly to cut down on footprint. We're incorporating either one-sided or two-sided MSE walls. So you have vertical faces. So you definitely have non-infinite boundary conditions. There are also times where embankments need to account for utilities, sometimes large culverts, where you have kind of a discontinuity in your load transfer platform. And also just an embankment that curves or an embankment that has a 90-degree corner on it. And, that is not explicitly considered in GeogridBridge 3. So you need to then look at tools that can handle 3D analyses. So you're looking at 3D numerical modeling, whether it's using the finite element method, the finite difference method, to account for those special cases. Now, in those cases, it doesn't mean that the utility of GeogridBridge is zero, because I think whenever you use a sophisticated tool such as 3D numerical modeling, when I talk to my students about advanced geotechnical analysis tools, I kind of use the metaphor of kind of increasing, layering on increasing sophistication to your analysis, starting very simple and kind of like tethering out, making sure you have like line of sight back to the more simple analysis. And so I think that really is true here. And so if you're going to be using a 3D numerical model for a column-supported embankment, you should, as part of your analysis, look at a cross-section that you can model using GeogridBridge 3 and make sure that the results, the comparison makes sense. Like, they don't have to align perfectly, but you as the designer should be able to explain the similarities and the difference. And at that point, you have some confidence, then you can then use your 3D model in cases where you can't use the spreadsheet.
Elise, anything to add to that? How many times did he call you out during class or doing your homework and say, did you check it with something more straightforward?
Oh, yeah. I mean, you learn to just do it before he yells at you in class, right? Yeah.
He pulls out the napkin and solves the problem on you, and you're like, ah.
I would say, like, the only other thing that I would add to it is that, like, in the early design phases, like, it's super easy to iterate using GGB3. Like, it's just like inputting different values into an Excel cell. And so if you compare that to like going straight into a large 3D model, like, there's so many blind spots for you to miss there. And it's very clearly laid out in this tool, which is, in my mind, like a huge benefit in the early stages, especially.
Yeah.
Great, thanks. Hey, Laura says hi. So Laura Spencer is asking, since you're talking about creep, can you talk about the difference and maybe hammer home a little bit of the difference between the tensile strength at 5% strain versus using a creep limit strain at 5%?
Right. So thank you, Laura, for the question. Laura also, I think, knows the answers to this. She's an author, a co-author on the paper I mentioned. So the question, I think, is about the tensile strength of 5% strain. I'm assuming she's referring to something that you would measure in a short-term tensile test versus something that's creep reduced. And so it's really as straightforward as taking the short-term tensile strength at whatever serviceability strain limit you want to design for, and then dividing by whatever reduction factors you feel are appropriate for that. And so you're going to end up with a tensile strength that is less than the short-term strength, because you're as long as your reduction factors are greater than 1, and you're dividing by numbers that are going to reduce that value. And that hoping I got at the meat of that question.
Okay. Any other questions out there? Last call here. Well, type them in fast. So I know we were talking a little bit earlier, Elise, but you mentioned that this opportunity to work on this during COVID kind of had an impact on you. Do you want to expand on that a little bit?
Yeah, for sure. I mean, I think for a lot of college students, especially in undergrad, like COVID was pretty isolating. We weren't able to go to like the conferences that a lot of classes would go to. We weren't able to do a lot of the sort of more social networking type things. And through the work here, I was able to interact with the DVGI section, the International Geosynthetics Committee, the GI Geosynthetics Committee as well. Eventually, we were able to make it to Geo-Congress, and that was like an amazing experience. And so I think professionally, this work, even though I probably started from a little bit behind compared to people in different years, I think this work really gave me an opportunity to dive fully in when I could, because I was able to have the research experience despite not being able to be like directly in the field in the way that a lot of it does require. And I mean, I think the involvement that I was able to get with professional societies during my undergrad year, especially having Professor McGuire be so involved in all of them, was incredibly transformative. It brought me to tech, brought me here. So I definitely view this project and this work as very important and very impactful on my professional life.
Awesome.
No,
yeah, I will.
It was excellent to have students like Elise and Eric to work with. So I was very fortunate.
And Mike, thank you for bringing your students and engaging them in all the committee work that you're involved in and the conferences. So it's great to see you getting the students out and getting them engaged. I will encourage everybody, the committees are open. We love having participation. Please come join the committee activities and any of the geotechnical societies out there. Come to the conferences. Building that network early helps you out long term, as Elise was indicating there. I think gave her a great foundation to get rolling in her career.
Absolutely.
And with that, Brad's back on the screen, so that must be a sign.
You earned your pay today, Alan. That was really good doing that little pitch right there. But I am going to ask that we do one more pitch. I put a poll in the chat as we were going through here whether people had ever used geotech tools or not, and almost half had not. Mike, do you want to tell everybody really quickly why they should use geotech tools? I guess what it is, and then why they should use it.
Yeah. So yes, if you're not using it, you're missing out. I use it as a course resource in some of my electives. I think at the beginning of this interview, I alluded to the Sharp 2 program that Joel Sloan was involved in, and one of the deliverables from that project was a website that was originally hosted and managed by the Sharp 2 project, and then eventually was kind of adopted by the Geo-Institute. And so the Geo-Institute is the custodian of this website, and I will hopefully continue to be for forever and ever. What you find, so first of all, it's free. All you need to do, you do need to create a login, but there's no cost. And you get into this website, and there is a large grid of technologies that you can learn about. And so whatever ground improvement technology you might be thinking about for a particular project, or if you want to learn about it, there is a bunch of really great information in there. Design guidance, references to key publications, in some cases, some information that will help you do some kind of initial cost estimating, get a start on developing specifications for a particular technology. The GI has some goals, also some goals moving forward for geotech tools. So there's some efforts underway to further build out the resources that are available on geotech tools, including some kind of fundamental geotechnical engineering information, kind of in a concise, easy to digest way. And so, yeah, I just can't underscore the value enough to practitioners and students that have at least some introductory exposure to geotechnical engineering.
That was awesome. Very nicely done. And I did put a URL to Geotech Tools in the chat so that people can click over there, create your account, go in, see what it's all about. And I guess we should make a plea too, that if you look at the information that's up there, especially the case histories, and you would like to submit something, reach out. Odds are good that we can work with you and make it something that we can add to the repository on the website. We would love to have it. Thanks, Alan. Thanks, Mike. Thanks, Elise. This was really good. I hope everybody clicked on that link and went over and started to make that purchase of those two manuals. Put them in your cart. Use that discount code, of course, that Leslie gave you at the beginning, and you will get 10% off. Tell all your friends as well. We did note at the beginning that this was our first live stream of 2025, but it's not going to be the only one. We'll be back on the YouTube channel in just 7 days with the third preview of Geotechnical Frontiers 2025, which is, of course, GeoCongress this year, plus the Geosynthetics Conference. You can hear a cool presentation about the Brent Spence Bridge Corridor that connects the great, I guess Kentucky's a Commonwealth of Kentucky with Ohio. Today, we also posted the first episode of our Geo Legends series for 2025, featuring John Schmertman, interviewed by Bob Bacchus. You will want to check that out. Director's Cut comes back tomorrow with regular episodes. We'll have Mike Gomez from the University of Washington, the 2025 Casa Grande Award winner. And Thursday, Field Trips returns with a special story from Tim Stark of the University of Illinois. So we have a lot going on over here at GI this week. You do not want to miss any of it. Again, if you liked what you saw today, and you're here at the end, so you probably did, click like, subscribe, and get notifications. We will let you know every time we post something to the YouTube channel. Alan, thank you. Mike, thank you. Elise, thank you. This was fun. You guys did a great job and inspired many to go spend their money with ASCE. Our producer today was Aurora Flieger, and we will see everybody very soon with more great content from the Geo-Institute.
Awesome. Thanks, Brad.
Yeah, thank you all.